Started recording.
Live streaming. Vinod, let us wait for 5 minutes.
Sure, sir. Let us wait, sir.
Okay, because only less participants join. So
Yeah. Yes, sir. Yes, sir. We shall wait, sir. Okay, sir.
Okay, Vinod, let us start the session.
Yes, sir. Fine, sir.
Okay, yeah, I request Professor Sadiq sir to introduce the good morning participants. Now I request my colleague Dr. Sadiq sir to introduce the today's speaker.
Good morning, everyone. I wish you a Republic Day. Jai Hind. Namaste, everyone. Welcome you all for ACT sponsored Friday's ATAL FDP on behalf of Rajarashri College of Engineering, Rajarashri Group of Institutions. On behalf of our principal, I would like to invite all the participants for the Day 3, Session 1. I would like to introduce the speaker. The expert speaker is going to deliver a lecture on Lean Manufacturing and Industry 4.0. Dr. S. Vinod, Associate Professor, Department of Production Engineering, National Institute of Technology, Tiruchirappalli. Am I audible, sir?
Yes, you're audible, sir. Proceed.
Dr. S. Vinod is an Associate Professor in the Production Engineering Department of National Institute of Technology, Tiruchirappalli, Tamil Nadu. He's completed his PhD from PSC College of Engineering, Coimbatore. He completed his master's degree in production engineering from PSC College of Technology, Coimbatore, and bachelor's degree in mechanical engineering from Government College of Technology, Coimbatore. He was a top ranker in his undergraduate and postgraduate studies. He has been awarded National Doctoral Fellowship for pursuing research by ICT, New Delhi. He has been awarded Highly Commended Paper Award and Outstanding Paper Award by the Emerald Publishers, UK, for the year 2009 and 2011. He is the recipient of Institution of Engineers Young Engineers Award for the year 2013-14. He has published over 150 papers in international journals. He is on the editorial review board of various international journals in specializations of manufacturing and industrial engineering. His research interests include lean production, sustainable manufacturing, agile manufacturing, rapid manufacturing, product development, and industry 4.0. Welcome you, sir. Dr. S. Vinod, sir. Welcome you, sir.
Yeah, thank you, sir.
Over to you, the session, sir.
Yeah, okay. Good morning, all. Republic Day greetings to all. So in this session, I'll be focusing on lean manufacturing and industry 4.0. So as a continuation to my yesterday's lecture, we'll be proceeding with the secondary tools of lean manufacturing, and also we'll be discussing about the lean manufacturing rules, and then I will proceed with the industry 4.0 concepts, technologies, then the relation between the lean and industry 4.0, how they are being interconnected, in what way, and also I have a set of research perspectives to be discussed, and also in value stream mapping, yesterday we discussed, I'll be showing few research studies as well. This will be my flow of presentation, and I request all participants to be interactive. So in any faculty development program, the kind of interaction is most essential. So any kind of questions, feel free to either post in the chat box, or interimly we'll discuss and then we'll take ahead. Okay. So with this, let me proceed with my presentation. Okay. So yesterday we discussed about the primary tools. We have 5S, TPM, and value stream mapping. And today we'll discuss about secondary tools of lean manufacturing. So for any lean implementation, basically it has to start with the primary tool. And the secondary tools will help in further analysis. And if you see in a practical scenario, hybrid approaches, hybrid tools will be applied. Say, along with primary tool, a set of secondary tools will be applied. So anyway, I'll be showing in research studies also how this kind of hybrid tools are being applied, because we need to keep in mind the real life scenario so that the kind of discussions will be more relevant. Okay. So these are nothing but the set of secondary tools we have. Let us discuss one by one. Okay, some of the tools maybe they had been prevailing in the field of total quality management and total productive maintenance and so on. But there are some exclusive tools for lean as well. Let's go one by one. So the first tool is cause and effect diagram. It's otherwise popularly called Ishikawa's diagram or the fishbone diagram, because the quality guru Ishikawa introduced this cause and effect diagram. Cause and effect diagram, its purpose is to analyze the interrelationship between the cause and effects. And we need to find out the root cause of the problem. Say in this illustration being shown, the effect is nothing but, which is on the head part of this diagram, is the poor delivery to the customer. When we analyze further these reasons or so-called the causes, we have main related, mission related, method, materials related, and so on. Or based on forums, it had been given. And if you see maybe like from a man perspective, there is no training, or maybe the absenteeism of the workforce, maybe like the commitment may be lagging, and so on. These are nothing but the primary level causes. Each primary cause should be further analyzed, because a cause and effect diagram will be more effective when we have more further branches in it. Say, for example, there is no training, it's a primary cause. We need to analyze further why there is no training. Maybe the management may not be willing to offer the training programs, or the workforce may not be willing to participate in the training programs, or maybe like such a kind of a culture may not be prevailing, and so on. Likewise, this could be the secondary cause. Maybe like when we take the machine perspective, frequent breakdowns are happening, or the capability of the machinery is not up to the level, or maybe like proper tools are not being utilized, and so on. Say old and frequent breakdowns, why does happen? Okay, maybe the downtime related issues, or maybe like if you see the maintenance procedures are not being followed effectively. Likewise, we have a set of secondary causes. And ultimately, this cause and effect diagram, the interrelationship between the causes and effects need to be analyzed. And we need to come out with a set of the root causes we should be able to identify. That is its significance. It has a lot more applications in the field of lean manufacturing as well. Okay. Next comes the Pareto chart. The Pareto chart is based on the Pareto principle, popularly called the 80-20 principle. So it states that the Pareto principle, it states maybe like 20% of the causes are called vital few causes, which contribute to 80% of the problem. But another 80% of the trivial many causes contribute only to 20% of the problem. But our focus should be on that 20% of vital few causes, which contribute to 80% of the problem. So if we see in this case, in this illustration being shown, so always normally if you see in the Pareto chart, that kind of that Pareto curve, that cumulative effect curve we need to draw. That is most important. The significance of that Pareto curve is nothing but we'll be able to find that 80-20 transition. If you see in this illustration, somewhere this 80%, if I try to find out that track this cumulative effect curve, always we need to track in the descending order of its magnitude. We could see the material defect, the machine availability, operator availability, and the downtime or the causes. They are responsible for 80% of the problem. Accordingly, the improvement actions need to be taken. The third one is called spider chart or radar chart. Yesterday in my presentation, I have shown this in some context. Any of the participants, could you get it from where we discuss this kind of, where we have seen this kind of a spider chart or radar chart yesterday? Are able to correlate? Yesterday I have shown in my presentation this kind of a spider chart or radar chart somewhere. Could you find out where I have shown? Okay, yesterday while discussing fibers, I told the fibers auditing we need to do, and we have to represent this course of fibers auditing on a typical spider chart or radar chart, because the spider chart or radar chart is used to represent the various parameters at a single shot, so that it reduces the voluminous reporting. So if you see here the target of 100%, productivity is lagging by 10%, and maybe like the available time is lagging by about 12%. Throughput is lagging by about 11%, and the attendance or the absenteeism of the workforce is contributing to about 5%. Lagging, the target is lagging by 5%. And similarly, the safety related issues are lagging by about 5%. Likewise, here, as Pareto Chart or ATAL chart will help us to analyze the various parameters, and it will help us to take the appropriate actions. Say here, we need to take utmost care on productivity. Why it is lagging by 10%? We need to analyze, and we need to come out with a set of solutions. Right. The fourth secondary tool is Poke-Yoke. It's a Japanese term, which means mistake proofing. So here, the scope of Poke-Yoke is it's a kind of a prevention device. It's a prevention approach, which will help us to avoid the occurrence of the mistakes. So as we know, the human workforce try to commit mistakes for several reasons. Sometimes it may be unintentional kind of issues also, and we need to make the system mistake proof, so that such kind of mistakes should not occur. So it's basically a prevention device which is used to avoid the occurrence of the mistakes. That's the significance of this Poke-Yoke based mechanism. Okay, if you see some practical examples of this Poke-Yoke mechanism, I could tell a few examples. Say while operating with the CNC machine tools, normally the door has to be closed properly. Then only the machining activity will commence. If the door is not being closed, then a kind of an signal will be indicated. Maybe a kind of a sound signal or a kind of a light signal also may appear. Some kind of an alarm sound we can get. So that it's an indication that the doors have to be closed. Then only the operation will start. And if you see other examples for this kind of Poke-Yoke thing is nothing but in the jigs and fixtures design, always we try to incorporate this kind of mistake-proof concept, this Poke-Yoke concept we try to incorporate, so that this the elements of jigs and fixtures are being designed appropriately with the Poke-Yoke concept, so that it facilitates the quick changeover, and thereby the production tooling is being incorporated with this mistake-proof aspect. The next secondary tool is Kanban. So again, Kanban is a Japanese term, which means the instruction code. It's an indication to initiate production. Whenever there is a need for or requirement for the assemblies or the manufacturing activities to start, the Kanban code will be an indication. So basically, it's a pull mechanism which is used to facilitate the transfer of parts, maybe from one location of the shop to another location. And it is based on the pull system. That means here any movement will happen only with the Kanban code. So the trolleys and containers will be incorporated with the Kanban code, so that this Kanban will deliver the right quantity of material to the right location at the right time. That's most important. That's a part. It is basically used in the context of pull production system. And this Kanban mechanism is more effective, and it facilitates not only the transfer of parts, but also it acts as a very good visual control, so that any trolley or container movement, when we want to track or when we want to see the focus of that particular movement, so that we'll be able to see the Kanban code. It's basically a simple code, maybe a kind of a manual code, or maybe kind of a digital card may be inserted, so that it will contain all details. There is nothing but what kind of a component it carries, from which location to which location, and how many numbers it carries, and what time it has to reach its destination. All the details will be available. And here, if you look at the design for the Kanban system, any movement of a trolley or container will happen only with a Kanban code. And a Kanban code will never accept the defective parts. That is the significance of the Kanban system. Okay, so we completed 5 secondary tools. As of now, any queries from participants? Any questions? Okay, let me proceed further. So the next secondary tool is automation. So it is an automatic signal mechanism that can indicate the status of any entity, maybe a machine parameter or a quality parameter, and so on. So normally it uses a kind of a signal mechanisms like light and sound signal. It is being incorporated with. So some of the conventions signals are being given here. Like when we have a red light and beep sound is a problem, or maybe like normal operations will be having a green signal, or if it's a quality problem, the yellow signal will come. So if you see this automatic signal mechanisms, when I visited few industries, I had an opportunity to see this kind of an automation mechanism. If you see this kind of a signal mechanism will be positioned on the top of the machine tool, these 3 signal mechanisms, so that the shop manager will be able to see from a further location that what is happening with regard to different machine tools, so that they'll be able to have a kind of view over the entire shop related activities and so on. These tools are very, very relevant even in the context of Industry 4.0. When I discuss about Industry 4.0 system, we'll be able to discuss about these kind of tools as well. Next one is, before we go ahead with the DFME, we have a single minute exchange of dice. That is SMED. Yesterday also we discussed about SMED. It facilitates a quick change of setups, because the change of setups have to be fast, because otherwise it will contribute to change over time, which may affect the lead time. So such exchange of setups is facilitated using SMED, single minute exchange of dice. Otherwise it is called quick changeover concept. It facilitates a rapid changeover of the setups. As per the Japanese theory, SMED, that exchange time between the setups should be very less, should be less than a minute. That's the idea. Level test we try to optimize. So that SMED is also very, very important tool. The next tool is DFME, Design for Manufacture and Assembly. So here it is all about how to consider the manufacturing aspects during design phase. As we discussed yesterday, we have a set of customer requirements. We need to convert it to design requirements and further process requirements and so on. In this translation, in this conversion, effectiveness is more essential. It's basically a cross-functional team approach. And what this DFME does is nothing but it tries to take into consideration the raw material aspect, manufacturing aspects, quality aspects, and so on, and assemblability aspects. So all those considerations need to be done during design phase, so that a design which is being made can be easily manufactured. That is the whole intent of DFME. So DFME is a very important concept which facilitates this kind of concurrent approach to design and manufacturing. Thereby, a design which is made can be ultimately manufactured and further assembled without any kind of issues. Because when we discuss about the kind of assembly, it's very, very important. Say, for example, we need to keep into mind this kind of the maintenance and service activities which happens after this product is being put into use. So their considerations need to be done during design phase. Say, for example, when I want to replace a critical component during maintenance activity, that critical component should be easily retrievable from the assembly, and the next one has to be inserted. In such a way, it should be. That is most essential. So this DFME concept is also very essential. Next one is JIT, just in time. As we discussed yesterday, just in time is a concept where whenever we get the customer requirement, it has to be We need to procure the material, manufacturing activity has to happen, the product has to be delivered to the customer. So just in time, raw material to be retrieved, component to be manufactured, it has to be delivered to the customer. So if you say some of the governing principles of a JIT system, we should not produce unless always we have a definite customer demand. It's based on pull system. And we need to link all the process to the customer demand through simple visual tools. Yesterday also we had seen value stream mapping, which is in line with that. And we need to maximize the flexibility of both the workforce and the machinery. And quality improvement should be there. The defects have to be reduced. And we need to control the raw material and finished goods inventory as well. These are some of the governing principles of JIT system. And also as a part of the JIT system, we need to consider the reliability of the equipment. Reliability of the machinery and equipment is also an important factor to be considered. And process capability of the machinery and equipment. That is most important, because if you see, in order to fulfill the customer requirement, we have a typical design requirement and the process requirement. But the machine tool should have the capability to fulfill that requirement. That's most essential as a part of it. That's the significance of JIT system. Next, the last secondary tool is the visual workplace. So here, as Lean is all about facilitating visual communication, we need to come out with the visual information, visual controls, maybe a kind of a manual boards. If you see in the shops, manufacturing shops, sometimes they may have the kind of a whiteboard, and they try to incorporate all the details. Say, for example, what is the target being attained in the previous shift? What is the target for the shift? How much they have attained and how much it's lagging likewise. And maybe a kind of a manual whiteboard can be replaced with a digital board. And if you see in the industries, they try to use a digital board wherein it tries to indicate that how much was the target and how much quantity they have produced, how much quantity they are ready to produce. Likewise, that the status updates will happen. It's very important. So definitely these kind of IT-based and electronics-based utilities need to be deployed so that all the workforce are aware of the kind of targets and what is being attained. Okay. These are the 10 secondary tools which we discussed. So as I mentioned, the secondary tools are will help the primary tools in further analysis, further investigations, and so on as a part. So any lean implementation naturally involves start with a primary tool and a set of secondary tools will be utilized. It goes with a kind of a hybrid setting normally. Yeah. Also, I would like to mention yesterday, in order to understand the lean concept, we need to have a very clear understanding on the elements, which we discussed to 5 elements, and a set of tools and techniques where we had discussed about the primary tools and secondary tools. And we went ahead with the next, we need to move ahead with the governing rules. What are the governing rules for a lean system? So if you see the rules, there are 5 rules which goes in the sequence, like stability, standardized work, full system, level production, and continuous improvement. First, we need to analyze what are the reasons for instability. So we need to make the system stable, because lean concepts can be deployed only in a stable scenario. In an unstable scenario, it may not be possible. So that reasons for instability need to be taken care. Next, we need to go ahead with the work standardization. So in that, we need to define every task. We need to find out how it is progressing and what is the best possible way to do it. Likewise, we need to examine as a part of it. And we need to go for arriving at the standardized procedures, standardized instructions, and we need to control the parameters like inventory, time, and so on. Once we go ahead with the work standardization, next we need to go ahead with the pull system, where we're trying to transform a push system to pull system. Pull system is based on purely working with the customer demand, and it tries to minimize the inventory to a greater extent. Next, we go ahead with the level production. Though we try to make the system pull, but we are not sure that the synchronization between the processes have been attained. Say, for example, there are 2 processes, process A and B. Both the processes have to be synchronized. In the sense, the process A should not go faster or process B should not go slower. Both have to be synchronized so that there is no accumulation of inventory, and we'll be able to attain the single piece. Next is continuous improvement, where we need to sustain the improvement, sustain the procedures, process, and so on. Okay. Next, I will proceed with the discussions on Industry 4.0 concepts and research studies. I'll be proceeding now.